Okay, this is IGCSE Physics 062562, paper 6, practical paper, experimental paper, May June 20. A student determines the resistance of a wire. Figure 2.1 shows the circuit he uses. So he has a resistance wire and he's sliding the contact, okay? So obviously, as you increase the length, there's going to be more resistance. The student places the sliding contact C on the resistance wire at a distance L equal 10. Record in the first row the potential difference, a V, and the current. So they want to fill in the blank here. Let's see. Uh, Over here, the V is how much? We have 1 and we have 10 blanks. So each one 0 0.1. So this is 0 0.1. This is going to be 0 0.2. Okay. And over here, 0 0.4, and we have 10 blanks. So 0 0.4 minus 0 0.2 is 0 0.2 over 10 blanks, 0.002. So, sorry, 0.02. So this is 0.22, 0.24, 0.26, 0.28. Okay. So over here, we're going to fill in for the voltage 0 0.2 and here 0.28. Okay. The student repeats the procedure using n equals 30, 50. However, they want us to plot a graph. To plot a graph, I'm going to take it into open board. Okay, I'm going to go up just a bit. Uh, Over here and zoom out just a bit. So, over here, this is our graphing place area, whatever. So, we're first going to plot our points. We're saying V against L. So, we're going to say V in volts against L, which is in centimeter. There's a mark for labeling your axes. Okay, we want to go up until 90. So you could say maybe it's 20, 40, 60, 80, 100. So we're going to use a scale of 20. The scale is according to your preference, and it depends on the person really. But I prefer using this scale that I just used now. Okay, then the V. Okay, our V is going up until 2.1. We could maybe go up until 2.5. So I'm thinking of using 0 0.5, 1.0, 1.5, 2.0, and then over here 2.5. Or actually no, it's fine, it's fine. 2.5 is good like this. Okay, now let's plot our points. We have 0 0.2, and we're not talking about current. Please don't mistake it. Centimeters, right? So at L10, our voltage is 0 0.2. So at 10, it's 0 0.2. So here we have 0 0.5 over 10 spaces. 0 0.5 divided by 10 is 0 0.05. This is 0 0.05, this is 0 0.1, 0 0.15, 0 0.2. So 0 0.2 is over here. And then I want at 10 centimeters. So this is going to be my first point. Okay? Make sure to label it with an X. 30, 0 0.7. So we're going to go up to 0 0.7. Remember, our scale is here, 0 0.05 for each one. So 0 0.55, 0 0.6, 0 0.65, 0 0.7. So this is 0 0.7. And we want to go to where? 30 centimeters. So over here. Okay, X. Uh, 50, 1.1. Again, we're going to go to 50 centimeters. We're going to go now to 1.1. 1.1 is going to be over here because remember, we're using a 0 0.05 scale. Okay, remember to put an X over each point. Okay, 70, 1.5. 70, 1.5. 1.5 is over here. 92.1, so you go to 90, which is over here. 2.1, so it's going to be up here. Okay, so we want a graph. Don't use a curve. Okay, so I was thinking whether to put a curve or whatever. So I'm just gonna use a line of best fit, okay? A line of best fit should include your first and last point, okay? So, oh, if my thing doesn't want, if my, like, oh, okay, maybe like, oh, oh, it ain't, okay. Let me just use the ruler. We have applications, ruler, okay? Okay, let's take this over here, okay. Okay, needs to go up just a bit. Okay, that's good. And we take our red pen, whatever, and draw our line of best fit. So this is how your graph should look. Draw a line of best fit. Don't draw a straight line graph. Please don't. Okay? Draw a line of best fit. If they tell you to curve, then draw a curve. They'd say draw a curve. If they say plot a graph, you're expected to draw a line of best fit. Okay? If they said a straight line graph, then you'd connect each point. Okay? Let's see now. So we plotted our graph. Let's check the marking scheme for the graph. This is another girl solving. I don't really agree with this because like I told you, I would prefer to connect the first and last point. So I think the person who solved this actually watched this over here. Uh, but because I'm making sure, even in the comments, she said that it should be a line of best fit. Okay, so if you see when they don't say anything, it should be a line of best fit. Okay. Uh, then here they're saying write a conclusion about the value of the current I in the position when the contact is changed. If you look at I, it's almost constant. Like it's almost constant. So I is almost constant. Let's check the marking scheme for this. By the way, the marking scheme for the graph is that one mark for the axes, the scales, that's 2 marks, and then just the points correct, and then good line judgment. Okay, we have all of these. Okay, and the axes have to be correctly labeled. Okay, don't put L here, V here. Okay. Uh, C, we said they said just any conclusion that matches the readings, and they said expect I constant. So anything that just makes sense. I is almost constant. Okay. Justify your conclusion by reference to your results. So basically, look at your results and justify it. You can list مثلا 0.28, 0.30, 0. I think that was 27, 0.28, 0.29. The values are almost constant. See, they're all close to each other. So now for part D, what do they say? Justification to match. Okay, expect I values are very close. Using the graph now, part D, determine the potential difference when the length equals 60. Whenever you see a question like this, you have to go to your graph, go to when you have 60. So you take your ruler, go to when you have 60. You want to go up. Why I'm doing this by this is because there's a mark for showing clearly how you obtained the result. Okay, so you go to your 60. Okay, and well, you take your graph. I don't know, let's put it in blue. Okay, and you slowly go up. A straight line, dotted line doesn't matter. Personally, and I prefer a dotted line. Just so like it's fancier. Okay, and how do I go back? Okay, then you take this, you reach here. So at this point, you go back, you take your ruler, and you go from this point. Hold up, hold up, all up. Okay, okay, hey, and then you go here, take your pen, and go see the value you got, and then you take your Haida, move here. Okay, obviously you don't make it this dotted, yani make at least show the line. Okay. So over here, how much is this? Is going to be 1.4. Okay, so VL should be 1.4. Why am I using this board? Sorry, 1.14, 1.4. And there is no definite answer. It's just as long as you get from your graph. It depends on your graph. That's what's nice about these questions. So thank you so much for watching, and good luck.